Bismillahirrahmanirrahim. Welcome to MIT. Today we are going to solve a question of mechanics from paper 9709/43 for the session May June 24. Let's see the question. We are going to solve question number 7. This is question number 7, which is the diagram shows a track ABCD which lies in a vertical plane. The section AB is a straight line inclined at an angle of 30 degree to the horizontal and is smooth. The section BC is a horizontal straight line and is rough. The section CD is a straight line inclined at an angle of 30 degree to the horizontal and is rough. The lengths AB, BC, CD are each 2 meters. A particle is released from rest at A. The coefficient of friction between the particle and both BC and CD is mu. So this is the coefficient of friction. There is no change in the speed of the particle when it passes through either of the points B or C. It is given that mu equal to zero point 0.1. Find the distance. Question number 8 is find the distance which the particle has moved up the section CD when its speed is 1 meter per second. So this is the question we are going to solve. Here from the statement we have come to know that there are three surfaces. Look, first surface is AB, second one is BC, third one is CD. Whereas among these three surfaces, surface AB is smooth. BC and CD, second and third surface, they are rough. So whenever we consider to calculate any quantity, we should not think all of them together. As the surfaces are of different natures, we will have to calculate them individually. Then, first of all, we will have to decide what to do. Let us see what are we given. Find the distance. So distance or displacement is there, which the particle has moved up the section CD when its speed is 1 meter per second. So velocity is given and distance is to be obtained. That means we will have to consider the concept of velocity displacement equation. So what is the velocity displacement equation? Equation is v square is equal to u square plus 2as. We will have to apply this concept. Now you may ask a question. For displacement velocity, there is another s is equal to ut plus half at square. So that equation includes time. As there is nothing related to time in this case, so we don't need to apply that formula. We will just repeatedly use this formula, that is velocity, acceleration and displacement, because velocity displacement is to be obtained and velocity is given, and in between them there is something lying with them, that is acceleration. So this acceleration is to be obtained. Now the question is, acceleration at point A and at point B is not same. At the same time, acceleration at B cannot be as same as at C, and the acceleration at C may not be equivalent to the point D or any of the points on CD. That means we will have to find out the acceleration individually, because the nature of the surfaces are not of same kind. So let's see, for the surface AB, first of all we will consider surface AB. Okay, and for AB we will have to find, as we have already decided, we are required to find acceleration. So for acceleration, all of us know that the most widely used concept of the motion law of Newton is going to be applied, which is driving force minus resistance force is equal to mass into acceleration. So let's start with the surface AB. So don't forget that we will find the acceleration individually, because without acceleration we cannot apply this equation, and this is the only equation we can apply for reaching our goal. So what is the most effective way to solve any mechanic problem is, first of all, you will have to decide the concept. That means you will have to plan the way you are going to solve. Here distance is given. Look, again I am showing distance is given, and speed is distance is to be obtained, and velocity is given, speed is given. That means you will have to apply a concept which includes distance as well as speed. If you don't plan at the beginning the way you are moving on, then definitely you are drowning in the oceans of confusion. So first of all, we will have to decide what to do. We have already decided that distance and speed based equation is v square is equal to u square plus 2as. We are going to apply that one, and for applying this formula, v square is equal to u square plus 2as, for applying this formula we should know one more value, which is acceleration. And for acceleration, what can we do? For acceleration, mostly what we use is the motion concept of Newton's law. So let's start applying the Newton's law for the section AB. First of all, we will consider AB. So let's start writing for AB, for AB, for A until B. Okay. And what is the concept? All of you know, that is driving force. Driving force minus resistance force is equal to ma. Well, now we will have to sketch the scenario. That is, here is AB. Okay, and in AB, let me draw it longer. So this is particle is over here. Okay, this is the particle which is sliding down, and we have seen from the question the particle is released from rest at A. That means there is no applied force acting on this. There is no external force. Only what it is doing, it is sliding down due to the weight, and the surface is smooth. So let us sketch this. This is going to be the vertical line, means normal reaction. Then this is the weight is acting downward, and we can form a triangle. Here angle in between them, angle is 30 degree. Let me show you that angle is here 30 degree. So we will write here this angle is actually 30 degree. This is 30 degree. Okay, 30 degree. So the we have already come to know that there is no external force acting on this, so there will be no driving force. Only driving force is what? Only driving force is the weight. This is weight. Weight is mass into acceleration due to gravity. So this weight is causing the particle sliding down. Now the weight is the force. Actually, we will have to find not weight, we require this horizontal line. I mean, we will have to resolve the forces horizontally and vertically. So this is our horizontal line. I mean, if in term of this, our reference line is this surface. Look, this surface is our reference line. Okay, so for this line, actually this is parallel, so the force which is acting on this will be also equivalent to this. So we will have to resolve the forces horizontally. If we assume this is horizontal line, then this will be the our vertical. This is, sorry, this is not horizontal line. According to this diagram, this triangle, so this is vertical line. So for vertical line, how can we write? We will have to write, we know that the length of, let me change the ink, the length of or the magnitude of the vertical line is, we know hypotenuse is mg, and for vertical line it will be sine 30 degree, because angle is 30 degree, minus resistance force. And we have come to know that surface AB, don't forget that surface AB was smooth. so there is no resistance force acting on this. That's why resistance force is 0. And mass into acceleration, mass into acceleration on the right side. So it is going to be our mass and acceleration due to gravity is 10. So it is going to be 10 m, and we know the sine 30, the value of sine 30 is actually half. So it is equal to ma. From both sides, if we omit m, there remains a is equal to 5 meter per second square. This is the acceleration at the point B. At this point we have got the acceleration. Okay, then we will see what is the acceleration at the point C. Already we have explained that the surfaces are of different natures. That's why one acceleration will not be applicable for all the surfaces. So let's find the acceleration at point C, and we are going to apply the same concept, that means Newton's law of motion. So let's write for BC, for B until C, for B until C. Okay, the same concept, driving force minus resistance force is equal to mass into acceleration. Now let's see what is the driving force for the section BC. BC is, I can show you over here, BC is nothing but a horizontal line. Okay, so there is no driving force and the particle is not being pulled or driven by anybody. That's why driving force is 0. Okay, driving force is 0. And weight, now you may ask a question about weight. So weight is actually, if you use, look at this, if we use this formula, mg sin 0, angle is 0. Okay, sin 0 is actually 0, so mg sin 0, this will also produce 0. That means if you ask a question that why are we not calculating weight here, weight is also one kind of force. So if we even consider weight, it will be 0 mg sin 0, because angle is, the line is, this is our line, horizontal line, so angle is 0. When angle is 0, sin 0 is 0, that means the driving force is 0. Or simply we can think that whenever we released the particle, there is no external force pulling it up or pulling it forward. That's why there is no driving force. So we will write driving force is 0 minus resistance force. Now we will have to find resistance force. We have come to know that surface BC and CD. Surface BC is written, BC is horizontal straight line and is rough. Look, BC is rough and CD is also rough. CD is also rough. So for rough surface, here resistance force is actually the frictional force, and frictional coefficient is given. Look, it's 0.1. So how to find the resistance force of a rough surface? That is mu r. So let's write mu r. It is going to be mu r. Okay, mu r. Mu r. R is normal reaction force is equal to ma. Now let's find mu r. This is actually our normal force. Okay, normal force is acting over there, and angle must be 0 actually. Okay, so we are going to write our minus, that is 0 is unnecessary to be written. Mu is our 0.1 and r. Let's find r. R is actually, if horizontal one, I mean the vertical, when we calculated this was our vertical line, so this is going to be horizontal line, and angle is 0. So it is going to be, let me show you, for this line, look at this, for this line we considered mg sine 30. Okay, sine 30. So definitely for this line, if we talk about this, because normal reaction acts upward, vertically upwards, so vertical line, it is actually now adjacent line. Okay, it is no more vertical line, this is horizontal line. So for horizontal line, how can we find? The same formula. For vertical line, if it is mg sine 30, and here actually for the new case, it is angle is 0. Okay, angle is 0 because this is the same line lying on this, so angle is 0. And for horizontal line, we will use cos. cos is opposite to sine, so we will write cos 0, mg cos 0. Let's write mg cos 0, mg cos 0 degree is equal to mass into acceleration. Now if we calculate, it is going to be m from both sides can be dissolved, and g is so negative zero point 0.1 into g, we know the acceleration due to gravity is 10 meter per second square, and cos 0 is equal to 1, equal to a. So what have we got here? For the surface CD, the acceleration is equal to what? Negative 1. Negative 10 into zero point 0.1, that is negative 1. So not CD, it's actually BC, second surface. BC acceleration is negative 1. Negative 1. So we have got the acceleration of the both ends. We should not be deviated from our concept. We are actually finding acceleration at this point, acceleration at this point, and acceleration above this, because they have told the particle moved up, and at the final stage the speed was 1 meter per second. So we have got the acceleration at B, acceleration at C. Now this is the turn of finding acceleration at D, or on this surface of CD. So, and we are going to apply the same concept, because we are looking for the same quantity acceleration. So let's start the same concept, applying same concept again. Let me write over here, this is for the last section, for CD, for C2D, for the surface C2D, and C2D is something like this. Okay, and look at this here, the angle is, weight is acting downward, the angle is 30 degree from the figure we have come to know, and our vertical, I mean normal reaction is working there, and we are actually bothering about this. Okay, we require this is our reference surface or reference line. Okay, so this line is actually parallel to this, we will find the force, and this is mg, we know weight is, force of weight is mg. Okay, now the concept, we have already applied the concept, driving force minus resistance force is equal to m into a. Okay, now let's see driving force. Actually there is no driving force at all, because the particle has been released. So remember, this is a crucial point, whenever a particle is projected or released, then there is no external force acting on this, so driving force is 0. Now resistance force for this, look, for resistance force is actually, this is the normal reaction we will have to find, as the surface is rough, so same formula, mu r. Okay, mu r equal to ma, equal to minus mu, the value of mu is zero point 0.1, we have already come to know, and r is, look, we are going to find the vertical, the force, I mean the weight which is contributing vertically, the vertical force, I mean normal reaction, normal reaction is actually, the direction is vertical direction, so it is mg cos 30. For horizontal one, we find always what? Sine, not horizontal. Actually, this is according to this triangle, it becomes vertical. If you just rotate it right onwards or clockwise direction, you will find that this triangle, this one is the vertical line, this one is vertical line, and this is horizontal line. So for horizontal line, as this is the weight always acts downward, vertically downwards. So we don't need to write the weight, actually we find the effect, or influence by the weight, and we resolve it horizontally and vertically. So this is our horizontal line, this one, though this is actually, this is not horizontal component, but according to this triangle, this is horizontal, this is horizontal. That's why cos 30 degree. Okay, cos 30 degree is equal to ma. Okay, Then from both sides, if we cancel out this m, it is going to be negative zero point 0.1, and cos 30 we know root 3 over 2. Sorry, we are missing one thing, that is value of g. Value of g is acceleration due to gravity, which is 10. So root over 3 over 2 is the value of cos 30, it is a. Hence our a is going to, acceleration must be negative as there is no driving force, whereas there is resistance force, so acceleration will be reduced and it will be negative. What is it going to be? It is going to be 2 5, so point 0.5 point negative zero point 0.5 root over 3, which is the acceleration at, not acceleration, deceleration at point D. Sorry, we skipped one more resistive force. Look at this, this is the particle is moving, particle is moving up. Okay, this way particle is moving up. So when particle moves up, then it is resisted, the force is resisted by weight. So there are two resistive forces. Let me write it once again. Before that, I'm going to erase this. Actually there are two resistance forces. One is, look at this, when particle moves up, then weight is trying to pull it downward. So weight is causing resistance force, as well as another force is frictional force. The surface is not smooth, so there are two frictional forces. Driving force is 0, and frictional, first frictional force is mu r. Okay, mu into normal reaction. Another resistive force is weight. Weight is also causing resistance, so that is mg cos 30 degree. 30 degree equal to m into a. Now we are going to find r. Okay, mu is zero point 0.1 and r is, actually I have explained previously that it is going to be mg cos 30 degree normal reaction. Okay, minus, this should not be cos 30 degree, it will be actually sin 30 degree, and I'm going to explain the reason why should it be cos. Actually we are trying to find this is weight. Okay, this weight is acting downward, and the particle is moving up. That means force should be horizontal, force should be resolved vertically. This is vertical line according to our triangle. Okay, so for vertical it is going to be sine 30, you know it very well, sine 30 degree. Okay, so mg sine 30 degree, 30 degree equal to right side. Right side is ma. So what have we done here? There are two resistive forces. One is weight. Weight is causing resistance to the speed or motion, and another one is the surface. I mean the rough surface. So for rough surface, the resistive force is mu r, and for weight, if we dissolve it that vertically, means in term of this reference line, reference surface, it is mg sine 30, because this is our line. Look at this, let me show you with different ink. This is our line. Okay, for this line, this is vertical line in term of triangle, but not in term of our surface. In term of surface, we are dissolving it horizontally. Horizontally means just parallel to the surface, but whenever we draw the triangle, it turns to be, because angle is over here and this is 90 degrees, so this is vertical line. And for resolving or finding the magnitude of the vertical line, always we use mg sine 30. Mg is the weight, this the hypotenuse. Well, so let us calculate. It is going to be, let me change the ink. Ink is supposed to be red. Well, so m is, look, very common in every case, so m can be dissolved. It is negative zero point 0.1, negative zero point 0.1, negative zero point 0.1. These are cancelled. So it is g, we know the value of g is negative zero point 0.1 into g. Acceleration due to gravity is 10, and cos theta is, cos 30, cos 30 is equal to root over 3 over 2. Using your calculator you can do so. and sine 30 is equal to half, and g value of g is 10, so 10 over 2, and right side is our just acceleration, equal to acceleration. Okay, then if we simplify, acceleration is equal to, here 2 can reduce this, or let us not cancel out, it is going to be 10 and point 1, so negative root over 3, and it is going to be 2 minus 5. Well, then ultimately our acceleration is going to be what? It is going to be negative root over 3 minus 2 fives are 10, minus 10. So this is the acceleration at where? At any point on, let us see here, this is the acceleration we have got at any point over here. Okay, now we have got the acceleration. Initially we have not forgotten that we are going to apply the concept of this v square is equal to u square plus 2as, and for that we have found a acceleration at different points of the surfaces. Now we are going to find the velocity, final velocity. Okay, one by one we will solve this. So our equation is v square is equal to u square plus 2as, and this is actually at what point? At the first point. Let us see, this is our first point. First we are finding at b. Okay, so we can write here v at b, okay, is equal to, as the particle was released from rest, so it is 0, and our acceleration was what? Acceleration is, let us see, at first point acceleration was 5. Look at this, this was the acceleration initially at b, so this is 5, acceleration is 5, and we know the distance, each of the magnitude of each of the surface is actually 2 meters, each one is 2, it is written over here. Look, each surface is of 2 meter, so we are going to write here 5, acceleration is 5, and displacement or length is 2 meters. Then ultimately it is going to be, hence our v is v at b. Okay, final velocity at b is square root over 20. Well, we have got one velocity. Now we will find the velocity at C. Velocity at C. Look at this point. So for the surface BC, this is the surface BC. So the velocity we have obtained at B is no more final velocity. This is now initial velocity. So assume this as initial velocity. We are finding the final velocity at C. So let's apply the same concept. It is V square is equal to, it's at C. Okay, V is equal to square root over, so u square, u was our this one is initial velocity, so square root, it is going to be square root over square plus 2as. Let us write the values directly. A is actually we have obtained at point B, our a was what? Our a was negative 1, so we will write here negative 1. Let's write negative 1, negative 1, and s is in all cases it's 2. So what is it going to be? Ultimately velocity at point C is 20 and minus 4. 20 minus 4 means 16, so it is going to be 4 meter per second. So velocity at point C is 4 meter per second. We have almost reached our destination. Look, we have got the velocity at this point, velocity at this point, and we are going to apply this formula, and ultimately they have told us to find what? The distance. Look, the distance which the particle has moved up the section CD when its speed is 1 meter per second. So here final velocity, look, final velocity at this point is given 1 meter per second, and we will have to find the distance, okay, between this C to this. So in the final case we are given the final velocity as well as initial velocity. We have already found the initial velocity, and final velocity is also given, so we know the acceleration at that point also. So let us write the last part of the solution. Let me go there. So this is the last part of our solution, and that is v square is equal to, or v is equal to, directly we can write, no, v square, let us write v square. V square is equal to u square plus 2as, and we are going to find actually s. So final velocity is given, just we have seen it is 1 square, so 1 square. Initial velocity is this is the initial velocity at c, so it is 4 square plus 2. Acceleration is this one we have obtained. Acceleration at c, acceleration at c is, so let us write negative root over 3 minus 10 over 2, and s is to be obtained. Okay, we are going to find the displacement or length or height it has traveled. Or 1 minus 4 square means 16, isn't it? So it is going to be actually 15, negative 15. Let me write it directly. So negative 15 is equal to, if these two dissolves this, it is negative root over 3 minus 10 into s. Okay, so let me write just below this. It is going to be, or if we isolate s is equal to 15. If we dissolve all of the negative symbols, it is going to be root over 3 plus 10. Hence our s is going to be, let me calculate this using my calculator. That is, sorry, it's a great mistake. Actually in numerator will be 15, so let me erase this. Numerator is going to be 15 and denominator is root over 3 plus, so this is root over 3 plus 10, and numerator is 15. Okay, and let me calculate this. 15 minus 15 over root over 3 plus 10, it is going to be 1.27. So if we round it up, it is going to be 1.28 meter. So that is what the solution is. So what have we learned? If I sum up of this answer, it is going to be actually, look at this, they have given, let me erase this again. According to the figure, there are three surfaces AB, BC, and CD. Whereas out of three, the first surface is smooth, and the second and third surface, they are of same length, but the last two surfaces are rough. So they, they have told us to find distance and speed is given. So first of all, we have decided that we will have to apply distance and velocity equation. V square is equal to u square plus 2as, and while we are going to apply this, we saw that our acceleration is to be obtained. So for obtaining acceleration, what have we done? We have applied the concept of the motion law of Newton, and in all cases it was same. So what have we done? First we have got the acceleration at different points: acceleration at B, acceleration at C, and acceleration at somewhere here when speed was 1 meter per second. After finding acceleration, then what have we done? We found the velocity. Applying the same concept, we got the velocity at different stage, and after finding the velocity, every final velocity has turned to be initial velocity, because velocity, final velocity at B for AB is the initial velocity for the surface BC, whereas the final velocity at C for BC is the initial velocity for CD. And applying this one, we have got the distance. Actually, the particle moved up 1.2 meter on CD, on the surface CD. That's all about C. I think you have understood. Then we will have to solve the next question, question number B. Let's see what B says. Question number B is at on this page. It says it is given instead that with the different value of mu, the particle travels 1 meter up the track from C before it comes instantaneously to rest. So let us sketch the figure once again. The figure will be like this. This this is AB and this is what? CD. Here A, B, C as well as D. So what has been given here? They have given us that we will have to find mu, what is the coefficient of frictional force, and the particle, look, particle went up. First particle went up, then definitely it will come down. They told that the find the value of mu and the speed. So there are two values missing, mu as well as speed of the particle at the instant it passes C for the second time. For the second time means first it has went up, then it went up, then it has gone back. Now we will have to find the final velocity at this point. Okay, so we will apply the same concept actually as we did in the solution number A. Well, if we recap, we will know that AB surface AB is smooth. So velocity at the point V B will remain same. Acceleration will also remain same. So let us write from question number solution number A. Let me go to the previous page. Here at B, look at this. Acceleration was this. Then for first velocity, look, velocity at B was square root over 20. So this will not get changed because the surface is smooth. Our frictional coefficient will not influence this one. So we will reuse this value. Let me write this over here. This is our velocity at B. Velocity at B. Velocity at B is equal to square root over 20 meter per second. We have extracted this from the question number 1. Then we will find the acceleration of the surface BC. It's actually all the same from the previous question. We can copy this for B to C, B until C. Actually, driving force minus resistance force is equal to ma, and we can just copy this because the surface is the same surface, just there is the difference in coefficient of friction, so that will remain as it is. Just we let us copy this from the previous page. Previous page was, look at this here. Look, this is for B to C. It was actually what? This was our actual notation. This is the equation. So it's actually A is equal to, just instead of mu, we instead of mu previously we have written zero point 0.1, but at this stage we will not write zero point 0.1, we will just leave it. So it is going to be negative, as there is no driving force, it will be negative. Let us write, it is going to be negative mu r is equal to ma. So it is going to be negative mu r, we have already obtained. It is going to be cos, sorry, mg cos 0 degree. I have explained in the first case why should it be 0 degree, equal to mass into acceleration, and both the m's can cancel out. Then it is going to be mu, negative mu is equal to acceleration. So for the surface BC, the acceleration is negative mu, not negative mu, there is g also, we cannot ignore. It's actually 10 mu. So acceleration is negative 10 mu, and it is at point, we can write at C. Okay, at the point C or at B, actually it's all the same. This is our one equation we can leave. For the same way as we did in the previous case, it was actually what? Now it is, the particle is going up. Okay, from it is C is over here, the particle is going up. Suppose particle has reached over this point and it is coming back. Okay, coming back to this. So what we will do, we will find that the speed at this point. Let us see the acceleration when the particle moves up on this, move up this surface. Okay, and it will be all the same actually. Let us copy from the previous page. From previous page we have written from C to D. It was actually this. Okay, this was our, let me show with different ink. This is actually our equation. So let us write it. We will write for section C until D. C until D. C until D. Driving force minus resistance force is equal to MA. What we are going to copy, there is no resistance, right, driving force, so it's 0, and let not it be written, and resistance forces are low. If I show you, there are two, though I have explained, again I am telling, here there are two resistance forces. One is, look, suppose this is our figure. Okay, in this figure, this is the angle, and this is our weight. Okay, so one is due to the rough surface, this is the resistance force. Another one is due to weight. Weight is also causing it pulling down while it is moving up. Okay, so one is, first one is, mu r. Another one is weight. Weight is mg cos 30 degree. Okay, mg cos 30 degree is equal to ma, and mu r is a normal reaction actually. So we have already, sorry, this is not a cos 30, this will be sin 30, because look at this, actually we are resolving this line. Okay, and this is parallel to our surface. So, and according to the triangle, this is actually vertical line. So for vertical line, we know hypotenuse into this. So it will be actually sine, not cos. Let me write here sine 30, sine 30. If for horizontal line, if we use sine 30, so definitely normal reaction acts upon upward. Okay, vertically upward, so it will be cos 30 mu, then mg cos 30 degree minus, this is mg sine 30 degree. Okay, 30 degree equal to ma. Ma, and all the m's can be cancels out, so it is going to be negative mu cos 30, we know root 3 over, so root over 3 mu over 2, and then there is g is what, 10, minus, here our g is 10 and sin 30 is equal to half, equal to a. So our acceleration is going to be here 5 root over 5 root over 3 negative, definitely 5 root over 3 minus 5 is the acceleration at c. We may write here c. Okay, and there is mu over here, we cannot ignore this. This is the major point, we are going to find mu. Well, we have got the acceleration at this point, acceleration at this point, and we can easily find the velocity at this point. So let us find the velocity when the particle was coming down. So we are going to repeat the same process we did in case of A. The final velocity at B will be initial velocity for BC, and the final velocity at C will be termed as initial velocity. So let us apply the same concept, which is V square minus, first of all let me write over here. Okay, it is V square, V is equal to square root over u square plus 2as. Well, it is going to be initial velocity from A. We have written that this is square root over 20. So square root over 20 square it was square root over 20 square plus 2 into acceleration. Acceleration was, let us find the acceleration. We got the acceleration as this. At this point, look at the acceleration is negative 10 mu. Well, so let us write negative 10 mu, negative 10 mu, negative 10 mu, and s, we know the magnitude of the surface is actually 2. Okay, so what is it going to be? It is going to be 20 square root over 20 minus 40 mu. 20 minus 40 mu is the velocity at what point? Velocity at point C. Final velocity at point C. Well, see, now when the particle was moving up, we are actually require when the particle moves up. Okay, this is at point C, velocity at point. When the particle moves up, then what is the velocity? And we know whenever a particle is released, it reaches at one stage, then it comes back. And whenever it reaches the final stage, the final velocity is 0. So final velocity we will write when 1 meter up. Look in the question, it is written when the particle was 1 meter, find the value of mu and speed of the particle at the instant it c for the second time. First of all, we will use for we require the value of mu. Okay, for value of mu we will use the final velocity as 0, because look at this, when one particle, suppose the particle is going up like this over here, then definitely at one stage it will stop and it comes back. Okay, so the final stage at the maximum velocity, it is acceleration, I mean it will be 0 instantaneously. It will stop and it will come back. So final velocity we will write, hence velocity, this is final velocity is we may write it as e. Suppose here there is e. Okay, velocity at e means final destination or final point. So velocity at e is equal to, we know that is u square. U square is our initial velocity was this, so square root over 20 minus 40 mu v square, this is our u square, plus 2as 2a, our acceleration. Let us find the acceleration when it was moving upward. We have just found over here, when it moved up, the our final acceleration is this. When the particle was moving up this, moving up through C, point C, then acceleration was this. It was minus 5 root over 3 mu minus 5. So let us substitute this, minus minus 5 root over 3 mu minus 5. And look at this, we have already come to know the particle moved up 1 meter. How much? 1 meter. Let me show you that a told particle moved up 1 meter. It is given the 1 meter. Here is 1 meter written, look. So our distance is 1 meter and final velocity must be 0. Okay, final velocity is 0 because when it reaches the highest culmination, then it is instantaneous rest. Then it is, what is it going to be? If we remove this square root, then it is going to be 20 minus 40 mu plus, not plus, it is going to be actually negative, 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 let me show full of this. It is going to be, okay, 2 5s are 10 mu, negative 10 mu, negative root over 3 mu minus 10. Okay, minus 10. Well, so after that we are going to, now you may ask a question, where has this square root gone? If this square root is converted to other side, we may write over here. Okay, even without this square root, so square root and square, they can cancel each other. There is no square, suppose there is no square root. Well, or what is it going to be? 20 minus 10, so that is negative 10. Negative 10 is equal to 40 mu minus negative 40 mu minus negative 10 root over 3 mu. We are searching for actually mu, so our mu is going to be, if all the negative symbols are omitted, then it is going to be 10 over 40 plus 10 square root over 3. Okay, then ultimately we will get our mu is going to be mu, hence our mu is 10 over 40 plus 10 square root over 10 root over 3. It is going to be 0.1738. Okay, so if we round it up, it is going to be 0.174, and mu doesn't have any unit, magnitude. That's why mu is not a unit actually. That's why there will be no unit over here. So we have got mu means the frictional coefficient. Now using this frictional coefficient, we will have to find out the velocity when it comes back. Let me show you the question once again. It says that find the value of mu. We have obtained its 0.174, and the speed of the particle at the instant it passes c. So second time when it is coming backward, then what was the speed? Well, we have got our mu, one of the answers. Okay, now the second answer is the speed, I mean velocity of the particle when it is coming down. So the scenario will be, let me sketch a graph. I will have to move on to the next page. Okay, this is our next page, and here look at this. The particle was 1 meter up. Let me draw this using different ink. So this is okay. So sorry, it will be like this. Okay, the particle is now what? Here is C, and it's 1 meter, and the particle is sliding down. Okay, and here angle is what? 30 degree. Angle is going to be 30 degree. Here is angle 30 degree. So we may write here, we assume this, suppose this is 1 meter, then the particle is moving down and weight is acting downward, and this will be our triangle. Okay, so what is the driving force in this? We will have to find the acceleration, again the same concept. So when particle moves down moves down. Okay, so driving for it is actually this symbol can be used. It is going downward now. Okay, so our concept is driving force minus resistance force is equal to mass into acceleration. So our driving force is, as the, look at this, particle is moving down, so it is actually weight is actually causing it down, what downward movement. So weight is this one. Okay, which is mg, and we will write mg. Okay, if we resolve the force horizontal, actually this is our vertical line, though in term, not in term of our what, in term of our surface. In term of our surface, this is horizontal actually, because this is parallel to the surface. So parallel to the surface is horizontal, and vertical to the surface is perpendicular. So as this is, but in term of this triangle, it is actually vertical line, and angle is 30 degree. So mg sine 30 degree, because this is vertical line in term of the triangle, minus resistance force. So resistance force is actually here the normal reaction, I mean due to the friction reaction, due to the friction, which is mu r equal to ma. So let us repeat, though we have written it earlier multiple times. So m can be dissolved from all sides, and it is 10, and sine theta is equal to what? Sine theta is equal to half. Okay, 10 over half, and minus our mu, let mu remain unchanged, or you can apply the value we have already obtained. Mu is our 0.174 or the whole quantity, without rounding it up you can use. And our normal reaction force is due to the friction, which is mg cos 30 degree, because if for this one if we use sin theta, then for this line vertical and normal reaction always acts upward. Okay, so we will find the net force of this normal reaction, that means upward and downward. If we calculate this, its normal reaction is mg cos 30, because mg is this one. Okay, mg is the weight, equal to ma. If we cancel this m, that is only a. So then it is going to be 5 minus our g is 10. If we multiply 0.174 by 10, it is going to be 1.74, and cos 30, you know, it is root over 3 over 2 is equal to a. Okay, then it is going to be actually 2 over 10 minus 1.74 root over 3. Root over 3 is equal to a. This is the acceleration at point C. Hence we can write acceleration at C is actually 10 minus 1.74 root over 3 over 2. Then we will apply the same concept. We are actually asked for find the velocity when it is, let me show you the question once again. The question says, this is the question, yes, this is question number B. It says we are going to find the value of mu. We have already obtained the value of mu, and the next one is of the speed of the particle. Okay, so for speed we are going to apply the same concept, which is let me write over here. Okay, the concept is v square, and you know the particle is what is going to be the particle, that is the particle. Suppose particle is from here, it is moving down, and when it moves up at one stage, it is at instantaneous rest, then it comes down. So final velocity is what? 0. So we can write here for final velocity, the final velocity while moving up will be initial velocity while coming down. Here suppose there is c over here. So let's write, hence we can write velocity is equal to velocity. They have told us to find the velocity while it's coming down or passing through c second time, is equal to square root over u square plus 2as, and it is going to be u is 0. We have already decided that the particle is coming down from instantaneous rest. So 0 plus 2, our acceleration is 2, and 10 minus 1.74, that is square root over 3, 74 square root over 3. Then if we calculate our velocity, it is going to be, this 2 can cancel this, so 10 minus 1.74 root over 3, and then whole over square root. So it is, my calculator shows it's 2.64 something. So if we round it up, it is going to be 2.64 meter per second. Okay, so this is the velocity when the particle was coming down. So if I sum up both the answers, let's go back to the question. The question was this. Okay, and here let me erase this. Well, there are three surfaces. First surface is actually smooth. Second and third, both the surfaces are rough. That's why we cannot calculate all of them together. And before starting the solution, I told you, may remember that first of all you will have to decide the concept you are going to apply. Actually here it's all about, look at this, they have given here mu and the distance. Look at this distance as well as speed. So distance speed equation is actually v square is equal to u square plus 2as. We have applied this concept multiple times. So for application of this, we may know the velocity, but we don't know initial velocity as well as acceleration. So for acceleration, we have found the acceleration at b as well as velocity at b for the first time, and final velocity of b for the surface AB is the initial velocity of BC. Same goes for this one. Final velocity or at C is the initial velocity for CD. Now the question is, what is the why is the final velocity of surface AB is considered to be initial velocity of B? Actually, they have given us this information. They have told there is no change in the speed of the particle it passes through either of the points B and C. That means when B at B and C, the before B and C and after B and C, at the instant of B, when the particle was at B, there is no change. So we can easily apply the final velocity of the earlier surface as the initial velocity. At the same time, the acceleration will also be used as for the next surface. So this is what we have done. Actually, everywhere we have applied the same concept. V square is equal to u square plus 2as, and we have got acceleration. But we couldn't do all of them together because the nature of the surfaces were different. First one was smooth, second and third one was rough. That's why frictional forces acted there. I tried my level best to make you understand. This is what A is, and the next one is over here. This is what B is. Okay, and if you have been benefited a little bit from my explanation, actually I tried my level best to explain every tiny part of this solution. So if you get benefited, then please pray for me to Almighty Creator for my betterment. Allah Hafiz.